Welcome. This is video 1 for section 1.2.1, which is our first module, topic 2, lesson number 1. Learning targets here. We're going to touch on 2 learning targets. One is I can apply the following properties of equality: addition property of equality, subtraction property of equality, multiplication property of equality, division property of equality, reflexive property of equality, substitution property of equality, and the transitive property of equality. And you're also going to be able to complete a 2-column proof. Now, we expose you to a number of different ways to do proofs in this chapter, in this topic. But the one that I really want you to come away with is being able to do the 2-column proof. It's the industry standard. If we're going to see a proof on the testing your junior year, it's most likely going to be a 2-column proof. So I want you to get real comfortable with this style. So the way the 2-column proof is set up is a T-chart. You got statement on the left side, reason on the right. Some textbooks will say justification on the right. So for whatever statement you make, you got to be able to give a reason or a justification. To do a proof, you always got to start with something that's given. Sometimes they just give you one thing, sometimes they give you a plethora of items. So you got to start with what's given, and then they got to tell you what they would like you to prove. So in this case, we're going to start with something you know, algebra, a basic algebraic equation here. So we're given this algebraic equation, and we want to prove that x equals 11. I'm actually going to do this proof 2 different ways. So the first way I'm going to do it is as if we were going to solve this algebraic equation. So as we go through this, I'd like you to think to yourself what the reason is, the justification is. If you need to pause and think a little bit longer, go ahead and do that. All right, so what's the first thing we're going to do to solve this? That's right, distributive property. So we're going to multiply these 2, and we get 6x minus 16 minus 4x plus 28 equals 34. Okay, this is going to be our second step. I almost forgot. Step 1, we gave this equation. What was our reason for that? Given. All right. What's going to be our reason for step 2? How can we go from here to here? I think I said it earlier. Distributive property. So it's going to be distributive. I'm just going to say property. All right. So what will we do next to solve this equation? Combine like terms on the left side. So let's do that. We're going to combine the x's and the numbers. So 6x minus 4x is going to give me 2x. Negative 16 plus 28 is going to be plus 12. And it still equals 34. So the reason if we do this, if we're going from here to here, our justification is combine like terms. All right. What's going to be our next statement we can make? Well, this is where we want to move the 12 to the other side, so we want to add the opposite, which would be negative 12, or we could say we subtract 12 from both sides. So we add negative 12 to both sides, or we subtract 12 from both sides, and we get 2x equals 22. So that is the subtraction property of equality. To save space here, I'm going to just say POE. Property of equality. All right. What are we going to do next? We don't want 2x, we want 1x. So we are going to either divide both sides by 2, or you could say you're going to multiply both sides by the reciprocal of 2, which would be 1/2. Multiply both sides by 1/2. Most of my students, when they have this, they typically like to say they divide by 2, so we will follow that method. And so our fifth statement is we get x equals 11. what's our justification or our reason? That would be the division property of equality. All right. I want you to note that's what we want to prove, x equals 11. What we want to prove will always be our last statement. That's what we want to prove. All right. Okay, I'm going to do the same proof a different way. There we are. Okay, same proof, but this time, same problem, but let's do it as if you were doing a check. And, you know, when you were in IM2, you did an equation like this, you solved it, your teacher always said, now you need, how do you know you got it right? You need to check it, and you use substitution process to do that. So we're going to do that here. We're going to take x equals 11. Again, this starts off with given. And we're going to substitute for the x with 11. So I'm going to go 2 parentheses, 3, go times 11 minus 8 minus 4 times 11 plus 28 equals 34. Okay? So all we did is took the 11 and replaced x with 11. And we kept the operation. So that reason is going to be substitution. Substitution property of equality. All right. So now we're going to go to solve this. So following the order of operations, we would like to simplify inside the parentheses. So we are going to keep the 2 here. And I'm going to keep parentheses, but 3 times 11 is 33. 33 minus 8 is 25. 33 minus 8 is 25. That's correct. And then I'm going to have minus 4 times 11 plus 28 equals 34. So what's our justification for step 3? That's going to be simplifying grouping, operations with groupings. All right, so now we've done our groupings. So next is the exponents. We don't have any exponents, so now we're going to look at multiplication and division, and we know the order of operations as we work left to right with that. So I'm going to do a multiplication here. So for 4, I'm going to get 2 times 25 is 50 minus, I'm going to multiply here, 4 times 11, so that'll be 44, plus 28 equals 34. So we're just going to say we did multiplication there. Just multiplication, not the multiplication property of equality. Okay, just multiplication. Okay, so then our next step is going to be addition and subtraction. We work left to right, so we're going to get 50 minus 44 is going to be 6. 6 plus 28 is 34 equals 34, right? And how do we get there? Addition, subtraction. Addition slash subtraction. Okay, again, not the addition property equality, not the subtraction property equality, just plain old adding and subtracting. All right, now are we done? We need to say that x equals 11. So our sixth statement here is we're going to say x equals 11, and justification would be because usually what you do in IM1 and pre-algebra, you just kind of check. So we're going to say substitution checks. And that's it. So that's your introduction to 2-column proofs.